Today we will discuss about the Newton-Raphson method. This method is generally used to improve the results obtained by one of the previous methods. It means that as the root finding algorithms, we have learned about interval bisection method and the fixed point iteration method. Using those two methods, we have identified solutions for the given expression. And now the obtained answer can be improved furthermore, or you can say it as the we can fine tune the answer using this Newton-Raphson method. Now we will consider about this Newton-Raphson method. We'll take x naught be an approximate root for fx equals 0. It means that we can say x naught is the root that we have already identified for the equation fx equals 0. But we will define the exact root. We will define the exact root as x1, and x1 is defined as x naught plus h. It means that this x1 is the exact root and x naught is the approximate root which we have already found, and this x1 is now actually h distance, or very small distance with h is away from this x naught. Therefore, x1 is the exact root and x naught is the approximate root, and the difference between these two values should be equal to h. Therefore, we are saying that even though we are having x naught as an approximation root for x, then we will get a value for this equation as a value which is very closer to 0. But since x1 is the exact root, then we will get if x1 equals 0. It is because one you all know, if you substitute the root in the equation, then the value that you are obtaining for such a function should be equal to 0. Now there is a concept called the Taylor series. Therefore, if you are having the function fx naught plus h, and if you are expanding this fx naught plus h using the Taylor series, then we can obtain it in this form. Therefore, fx naught plus h can be written as fx naught plus h times 1 factorial into f dash x naught, where f dash x naught is the first derivative of f, the function f at the point x naught, plus h squared divided by 2 factorial into f double dash x naught, is the second derivative of function f at the point x naught. Likewise, you can go or you can continue this up to infinity. Therefore, this is the expansion of a function using Taylor series, and for this method, we are neglecting all the higher order derivatives. It means that we are not going to consider, or we are not going to have an attention towards any higher order derivative. Therefore, up to the first order derivative, we will consider the term. Therefore, we can have this function if x naught plus h as if x naught plus h times f dash x naught. It is because the factorial 1 gives you the value as 1. Therefore, h divided by 1 just remain as the value as h. Therefore, we will get fx naught plus h equals to fx naught plus h times f dash x naught. Therefore, what we can obtain is we can now use this equation to obtain a value for h. Therefore, we can obtain the value of h as the minus fx naught divided by f dash x naught. We will get it in this way. Using this equation, what we can do is, using this equation, we can get this h equals fx naught divided by f dash x naught. Therefore, for a better approximation than x naught, we can get it by the x1. It is because we have defined x1 as the exact root. Therefore, in here also, we are using the iteration method. Therefore, using an appropriate iteration, then appropriate number of iterations, then we can go for a better approximation than x naught. Here, x naught is the approximate root that we have obtained using interval bisection method or the fixed point iteration method. Now we will see we have already defined x naught. Therefore, the new value x1 can be obtained using this equation. Therefore, the new value or the better approximation than x naught is x1. Then x1 can be defined as x naught minus h. x1 can be written as it is because you have defined x1 equals x naught plus x. It is the initial, it is at the initial stage what you have defined. But now you have identified that x equals fx naught divided by f dash x naught. Therefore, once you substitute the value of h in this equation, then you will get this as x1 and this equals to x naught plus the value of h is what? It is minus fx naught divided by f dash x naught. Therefore, once you solve the bracket, plus into minus becomes plus. Therefore, you can get the value of x1 equals to x naught minus fx naught divided by f dash x naught. Now, you are having somewhat a better approximation than x naught. Therefore, using the iterative method, then you can have find much more better approximation than this x1 also. Therefore, the next in the next iteration you will get the value as x2. Therefore, you are using the previous value x1 minus f x1 divided by f dash x1. Therefore, the value obtained at the previous stage is now used to obtain the next value of x. Therefore, using such iterative method, what you can do, what you can obtain is you can obtain value for xn plus 1. Therefore, value of xn plus 1, we are saying it would be the best approximation or the fine-tuned answer for x naught. Therefore, once you are coming up with this n number of equation, then you will get this as n plus xn plus 1 equals to xn minus fxn divided by f dash xn. Therefore, we are using this concept to fine tune the answer obtained from the previous method. Therefore, when you are using an iterative method or the iteration method, then there should be a stopping criteria. Therefore, the stopping criteria for this Newton-Raphson method is if the absolute value of difference of xn plus n, xn is less than the predefined error limit, then we can terminate the calculation. Therefore, once you are having the predefined error limit, as soon as you got this value less than the predefined error limit, then you can terminate the calculation. Therefore, now we will look about some examples related to Newton-Raphson method. In this example, they are asked to use the Newton-Raphson method to find the root of the equation x cube minus 2x minus 5 equals 0 with an accuracy of 10 to the power minus 3. And they have given the initial answer. It is the consider that x naught equals 2. Now, you know about these values. Now you know what is the value of x naught is equals to 2, and you know the predefined limit epsilon value, it is 1 into 10 to the power minus 3. These are the values that you are knowing so far. And the equation you are having is x cube minus 2x minus 5 equals 0. Therefore, what you need to do is if you are using Newton-Raphson method, you should have a expression in the form fx equals 0. Now you can see that this equation is equal to 0. Therefore, you can define fx as this x cube minus 2x minus 5. Then, once you know the equation of this fx or the function fx, then you can use the differentiation or you can take the first derivative for fx and you can take it as f dash x. Therefore, the derivative of fx is now equal to 3x squared minus 2. Therefore, the derivative of fx is f dash x. Therefore, we can get it as 3 times x squared minus x. It is because we know that the xn plus 1 is equal to xn minus fxn. To get the value for fx and we need the function fx. We know the value for function. We know the expression for function fx, and the next thing we need is f dash xn. To substitute the value of xn, we need to identify the first derivative of function f. Therefore, we will get the f dash x. Then what we have to do is, as soon as you identify the fx, you have to obtain the first derivative of this function. If you move for the next step, then you have already identified xn plus 1. The relationship between xn plus 1 is xn plus 1 is equal to xn minus fxn divided by f dash xn. But you have anyhow already identified values for fxn and f dash xn. It's because here fx is equal to x cube minus 2x minus 5 and f dash x is now equal to 3x squared minus 2. Then what you can have is, in the place of x, here we are having x, but here we can see now new value is xn. Therefore, in the place of x, what we have to do is, now you have to replace the value of x from this xn. Then what we are getting is xn plus 1 is equal to xn minus xn cube minus 2 times xn minus 5 divided by 3xn squared minus 2. Now you have identified the relationship between xn and xn plus 1. Therefore, we can now go for the iterative method. Therefore, we have to, if you are going for the iterative method, then you have to again create a table. In the first column, we are showing the iteration number, and then what we can do is we can obtain value for xn plus 1. Here we are setting in value in as 0 is because here we are using x naught to obtain the value for xn plus 1. Here we are having xn value, and using this xn value we are obtaining xn plus 1 value. Initially we have given the value for x naught, therefore we have to set n equals 0. Therefore, once we set n equals 0, now we'll see how we can get this xn plus 1 value. Here we can use the calculator. I hope you all can see the calculator also. Then what you can do is, now you have to include, or you have to give the input for this function in the calculator. Then first of all, I will include it in the calculator, and I will take the letter a as xn plus 1, and this is now equal to x, and I will take it as this x minus, then I am having the function, here it is again x cube minus 2 times x, 2 times x minus 5, and in the denominator we are having 3 times x squared minus 2. Now you have given the initial function, and we have to run the loop since we are using the iterative method. And the answer that you are obtaining for a is now used for the next value of x. Therefore, now you can separate the function using this colon notation. Therefore, in the next stage, the value of x should be the answer that you are obtaining at the previous stage. And now we will give the value. Therefore, we have to now give the value for x. The initial value for x given as 2. Once you substitute that value, then you will get the value of xn plus 1. We have taken that value as a. The value of a, or this xn plus 1, is now equal to 2.1. You can write it here, and then we will set n equals 1. At the n equals 1, we will get x equals to, the value for x2. It is because now you already know the value of x1. Then you can substitute it in this function in the right hand side of this function. Then you can easily get the value for xn plus 1. It is the x2. Now you have to set this as the value of x. Therefore, we can use equal sign again. It means that x equals the answer. We are setting new value. Therefore, now you can see that they are asked us to confirm whether the new value of x is 21 divided by 10 or it is 2.1. Therefore, we will get the next stage as the 2.094568 for 0.94568121. Therefore, value of x2 is now 2.0945688121. And if you see about these two values, it is in the first decimal place, it is quite different, but anyhow, I have calculated the value. Now you can see that the error between first two values are 5.49 into 10 to the power minus 3, but the predefined error limit is 1 into 10 to the power minus 3. Therefore, we cannot stop from this point. Therefore, we have to continue the calculation furthermore. Therefore, if I continue for the next iteration, then I will set the value. Then I am getting the new value as 2.094555 1482. Therefore, once you compare these two answers, then you can see that first decimal places equal, second, third, up to fourth decimal places are equal. Therefore, most probably at this stage, you will get the value. It is because you just need to get the value with an accuracy of 1 into 10 to the power minus 3. 10 to the power minus 3 means up to the third decimal places, or most probably up to the second decimal places. If it is equal, then we will get the answer which is less than this epsilon given value 10 to the power minus 3. Therefore, in here you can see that the obtained error limit is now 1.66 into 10 to the power minus 5. Therefore, you can terminate the calculation at this stage. But anyhow, I have continued one step ahead. And even though it is continued, we are getting the same answer. It means that you are getting the value as 0. It means that since the predefined error limit is 1 into 10 to the power minus 3, then you can define the answer as x equals 2.09455148 and here I have fixed it for 4 decimal places. Therefore, I have obtained the value as 2.0946. Then this is how we are using the Newton-Raphson method to fine-tune the answers obtained using interval bisection method or the 6-point iteration method. And I will discuss one more example for this. This is related with the radian measures. Here they are asked us to calculate the fine-tune the answers using Newton-Raphson method for the equation x times sin x plus cosine x equals 0 with an accuracy of 10 to the power minus 4. And they are giving us the initial root. They are asking us to set this x naught or the initial root is equal to 1. Now we have to identify the appropriate values which we need for the calculation. Value for x naught is now equal to 5, and value of epsilon is, or the predefined error limit is now 1 into 10 to the power minus 4. 10 to the power minus 4. Now they have given the equation x times sin x plus cosine x equals 0. Then you have to make it in the form of fx equals 0. Now you can see that it is actually in the form of fx equals 0, and you can identify the function for fx is x times sin x plus cosine x. Since you have identified the function for fx, then what you have to do is you have to take the first derivative for fx with respect to it. Once you obtain the first derivative, then you are getting this f dash x equals to x times cosine x. This is equal to now x times cosine x. Therefore, now you can combine this fx, f dash x, and this value xn to obtain an expression for xn plus 1. Once you combine these two fx and f dash x and xn together, then you can get the xn plus 1 is equal to now xn plus xn times sine xn plus cosine xn divided by xn times cosine xn. Here we are including the function fx by replacing the x with xn. Here we are getting this as f dash first derivative xn. Okay. Now, since you have identified this xn plus 1, the function for xn plus 1, now you can use the iterative method to identify the values. If I clear about these parts, then I will get the iterative value. We have to prepare the table in this form. Then we will get the first column for n, second column for value of xn plus 1, and third column for the error. Now we have to include or insert the function inside the calculator. Therefore, I will insert this function in the calculator. But prior to insert this function in the calculator, first of all, we have to pay our attention. What is the measure we are using? Here, we are using the radian measures. But in the calculators, normally we can see the letter D appears here. It means that we are using the degree measure. Therefore, first of all, we have to convert our calculator for the radian measures. Therefore, you can choose the option 4 to convert it as radian measures. Now you can insert the function. Therefore, once you insert the function, I will let xn plus 1 as a, and this is equal to xn I will take as x minus, then the function is x times sin x times sin x plus cosine x plus cosine x, and this has to be divided by x times cosine x times cosine x times cosine x. Okay, now you have insert the first function, but you have to, since you are using the iterative method, therefore you have to insert a loop inside this calculation. Then the answer you obtain at this stage will be the answer that you are considering for the value of x. Then you have to set this x is now equal to the answer obtained at the previous stage. Then you can set this for calc now. Now they have given the value of x as p. Then you can set value of x is now equal to p, and you are getting the value of x1 is equal to now 2.8232.82767. Now you can see the value here as x1. Then this value would be considered for the appropriate or the x value for next iteration. Then you have to set the answer as the next x value, and you can confirm it. Then you can take the value of x2 is now equal to 2.798599.894. Then once you compare these two values, it is different from the very first decimal place. Therefore, I will continue for the next iteration. Then I will get the next answer as 2.7983866062. Then if I compare these two values, first decimal place is equal, second equal, third equal, fourth decimal places are not equal. Therefore, anyhow, I have compared this value. Now it is given, it has obtained as 2.13 into 10 to the power minus 4. But the predefined error limit is 1.1 into 10 to the power minus 4. Then we cannot terminate. Then we have to go for the next iteration. Therefore, Once you set the value of x as the previous answer, then you will get the answer as 2.79838646. Now you can see that error limit is quite smaller than this predefined error limit 1 into 10 to the power minus 4. Since we have obtained an error which is less than the predefined error limit, then we can terminate the calculation. No need to calculate furthermore step. Even though if you check for the next step, if you if you like to test it, then you will get the value for x5, and it is now equal to, you can see that in the calculator, value is same as previous. It is just the 2.79838604. Therefore, now you can see the error between these x5 and x4 is now equal to 0. But we do not need the error as 0. The predefined error limit as 1 into 10 to the power minus 4. Since we obtain that error at this stage, then we can terminate the calculation from n equals 3. Then the required root can be given as 2.79 and you can round off to 4 decimal places, then we can get the answer as 2.7984. The main thing which you have to keep in your mind is when you are dealing with this radian measures, definitely you have to convert your calculator into radian measures. Otherwise, the values will not same as this if you're using the degree measure. Since we are not using degrees here, definitely you have to convert the calculator into the radian measures. And here I have include one another exercise. Then you can go through that exercise as the practice. Mm, um, Here it is given an interval also, but for this calculation, actually this interval may not be necessary, but you can identify once you obtain the answer, then your answer will be definitely lies in between 0 and 1. Therefore, you can try for this exercise, and thank you all for joining in this session.